everyone, so today let's do this. Wow. Okay, so let's understand.
Hello everyone, in this video we are going to make one mini security alarm system, and this is the circuit diagram of mini security alarm system. We are going to implement this circuit diagram into the breadboard. For that we need the components like 2N 2222 NPN transistor. This is BJT, that is bipolar junction transistor, and we are using three register here. Two, we are taking 2.16 kilo ohm register, 2.16 kilo ohm. We are taking two register like this, and one 3.1 kilo ohm register. So here this is the arrangement of voltage divider, and for output we are taking buzzer and LED. This is the switch, and 9-volt battery for the source power supply. Okay, the core concept of this circuit diagram, how does it work, is here the BJT or the transistor act as a switch. We know there are four mode of operation of BJT, and here in this circuit this BJT is working in two modes. It acts as a switch, means for turning on and turning off the circuit. Okay, for turning on, the BJT is in saturation region, and for turning off, the BJT is in cutoff region. So how when does the BJT turn on? When the base emitter junction and the collector base junction both are forward bias, then the BJT will turn on. And when the base emitter junction and collector base junction are reverse bias, then the BJT is in cutoff region or off state. Here the voltage divider arrangement, these register 3.1 kilo ohm register and 2.16 kilo ohm register set the bias voltage for this base, and ensure that the voltage between base and emitter, that is the VBE, is greater than 0.7 volt. When it is greater than 0.7 volt, then this will trigger this transistor. When the voltage between the base and the emitter is more than 0.7 volt, then it means that we are giving the positive trigger to the base, and it means the transistor is in saturation region, and it will turn on, and this lead to the current flow through the circuit, and the current will flow through the circuit, and the buzzer will make sound, and LED will start to glow. So let us implement this circuit into the breadboard. So this is the circuit implementation of the same circuit diagram on the breadboard. We can see that here is, this one is the transistor, this is the buzzer, and these three are the register. This is the jumper wire connecting this register to the emitter, and here this one is the LED, and this is the power supply of 9 volt. We can see this is the transistor having the flat part on the front and the curved part on the back. So let us try to understand how you can identify the three terminals of the transistor first. So this is the transistor. You can see the flat part, the shiny part. Here the specification, the transistor specification are written, or the numbering is written. Okay, so if you keep the flat part on the front, the first pin, the first lead is the collector, base. The second one is the base. This is the collector, base, and emitter. Okay, from the flat part, if you see, this is the collector, base, and emitter. Here this is the front part, so this is the collector, this one is the collector, base, and emitter. So we are seeing here from the circuit diagram, if you see the collector part here, the collector part connected to the positive terminal, we are giving the positive connection anode here, and the negative part, the emitter is connected to the negative part, emitter to the negative part here. Okay, and middle one is the middle one is the middle terminal is the base. So this is the circuit arrangement. This is LED. LED is connected to the collector part here, buzzer and a register and LED. This is the buzzer and this is the register limiting, rather you can say this 1.16 kilo ohm register is placed in series ahead of LED, and this limits the current that is flowing through the LED, and it protects the LED so that it won't burn out. Okay, so if we give the connection here, you can see it will make sound and the light will glow. So let us see. Yeah, so this is what we have in this video.